Hello, this is John Oti. In this third part of the Magsimus Deluxe tutorial, we will complete the build-up of the design we started in part 2. We will demonstrate how to add electrical circuit and mechanical motion attributes to the design. Here is the state of our design thus far from part 2. We created and populated the first group. We still intend to add more design components. Let us forge ahead and add 2 more groups to the system. We will use different techniques to add the groups and components. Groupings of components are typically used to organize them into functional roles. At the Design Manager, we click the Add Group Action button. We specify a new group origin. These inputs are measured in the system coordinate frame. Choices from the input type box allow us to specify how the origin data is to be interpreted. We click OK to close this dialog box. We rename the node. Let us add a probe component to the group. A probe does not represent a real object, but usually represents a field point. Let us enter a new origin coordinate. Let us specify an output curve. This will be a component of the magnetic field due to electrical current sources that the probe senses as it moves in space. We click OK. We rename the probes node. Let us click the Zoom Full button to bring our components into view. You can see the probe right here at the bottom. Let us add another group using the shortcut menu. We enter new origin inputs. Click OK. We rename the node. Next, we add an array component to the group. An array is a rectangular lattice of single domain cells. We select the group node and we click the Add Array button. Over here, we specify the size of a cell of the array. Here, the spacing between cells, and right here, the array grid dimensions. Let's specify an output curve. This will be an MH curve. There. We click OK. We rename the node. We click the Zoom Full button. Here is the magnetic array in the display pane. The red arrows represent its magnetization vectors. Next up, we will create an electrical circuit for the components of our very first group. You may recall that we specified an electrical current output for one of the components of this group. The electrical circuit that we are about to create will produce this current. But first, here is a brief overview of electrical circuits in Magsimus Deluxe. Whole groups are the circuit components in system-level circuits. The circuit we are about to create is a group-level circuit. Back in our Magsimus Deluxe session, let us double-click the group node to open its Properties dialog box. We select the Electrical Circuits tab. This is a complicated tab. We will skim through to give you an idea how it works. You can learn more from the Help button and by referring to the user manual. A circuit diagram of the group is drawn in this box. The components are drawn as rectangles in the box. This notation 2U, for example, means that this is the second group component and that its positive current direction is along its U axis. To make electrical connections between any two components, they are arbitrarily designated as source and destination components by clicking one component with the right mouse button and the other with the left mouse button in the circuit diagram. Let us do just that. Let us change the positive current direction of the source to W axis. Notice that its notation here in the circuit diagram has changed accordingly. Over here in this cluster of controls, we can connect the components. As I check the boxes, the connections appear in the circuit diagram. Let us leave it at the parallel connection of the components. For a group with many components, you may realize quite complicated circuits through the pairwise connection of the components this way. Let us connect a current source. We select the Custom Current Profile option. Here is the current source in the circuit diagram. We click this box with the ellipsis to open a dialog box for specifying the signal waveform for the current source. The dialog box allows the creation of an electrical current waveform, also called a profile, from a sequence of independent current legs. Our profile will have just one leg. You can select a profile type from the I-type box. Let us leave unchanged the current selection, pulse train. We click the Add button to create a new pulse train leg. Let's enter some data. We can see what this signal is going to look like by clicking the preview button. Let's close the signal preview window. Let's click OK to complete the signal definition. And finally, let us exit the group dialog box by clicking OK. Using the System Display Shortcut menu, we will now make the electrical circuit we just defined visible. There. This is a depiction of the current source, and the blue lines are circuit connections. You can imagine them to be small connecting wires. By clicking parts of the circuit and using normal mouse drag actions on the handles, we can conveniently position the circuit to our liking. Mechanical motion can be defined for groups. The group moves as one whole unit with the relative locations and orientations of its components preserved during the motion. Let us define motion for the second group, the probe holder group. This motion will be a rotation about our first group. We double-click the group node. We select the Motion tab to begin defining the motion. A group's motion is made up of an arbitrary sequence of motion legs, each of which can define separately a translation or rotation or both together. By careful definition of different motion legs this way, motions of varying complexities may be defined for a group. We define just one rotational motion leg for our probe holder. We click the Add Leg button to create this leg. We enter the number of motion steps here. We enter the angular velocity of rotation here. The entered specifications define the rotation of the group by 20 increments of the polar angular coordinate at the rate of 18 degrees per step. This results in a 360-degree rotation. We click OK to exit the dialog box. Let us preview the motion we just defined by clicking the Show Motion button. The probe undergoes the defined rotational motion and then returns to its starting position. Let us complete adding components to our design by importing our last one. To do so, we click this button, the Import External Component Action button. The Importing Components dialog box is displayed. We click the design file of interest in the file box. Its structure and views are displayed in these two boxes at the bottom. We click Import to add the design. The components of the external file are now imported into our design. We click the Zoom Full button, and there we have it. The imported component is a permanent magnet that can move. The ability to import external components is a powerful design tool. It can foster the independent optimization and the reusability of components. And with that, we come to the end of part 3 of the Magsimus Deluxe tutorial. Here is a recap of what we learned and a preview of what's next in part 4. Thank you.